Hey everyone, this is Jag Bains, VP of Solution Engineering, and I'm back to discuss how to configure the V5 load balancer to your backend servers.
Link 11 is your trusted cybersecurity partner.
The Link 11 V5 WAP allows users multiple options for handling high traffic to your backend servers. The load balancer, or backend services feature as we like to call it, ensures your applications stay fast, scalable, and resilient, and accommodates a multitude of different topologies, whether your origins are in the cloud, within an enterprise network, or perhaps in a hybrid of both. When your Link 11 WAP instance receives a valid web request, the backend services engine within V5 will intelligently distribute those requests across multiple customer origin servers, preventing overload and maximizing uptime. You can define multiple origin servers and select different load balancing algorithms to automatically route traffic only to healthy servers. Let's see how it works. Let's start by looking at the load balancing area in the customer portal. You can find it by navigating to the Sites menu on the left-hand side and then selecting the Backend Services option. Once there, you will be presented the current working configuration for your backend services. The key fields here include name. This column provides the name of a config for each row, defined by the user at the time of creation. I'll show you how a config is created shortly. The user can employ any naming schema that makes sense to their organization here. There is the host column, which details the actual origin server itself. You can configure it as a standard IPv4 address, a DNS-based A record, and of course, a CNAME. There's a transport protocol. This shows the type of communication protocol between the Link 11 WAP and the origin server, which I will detail in the next section. And finally, there's a stickiness model, which defines the method used to ensure a visitor to your site is routed to the same origin server during the entirety of a web session. Each of these columns is searchable by the filter button available here. The filter option presents a search field for each column, allowing for multiple search options. There's also a download option where a JSON file is created with the details of your configuration. Finally, there is a version history option that provides a historical view of all changes specific to your backend services. Please see the version control video for more details about this specific function. Let's continue on and walk through a setup of a new backend service. To create a new backend service, click the New button on the right-hand side. From there, you'll be presented a configuration panel with a number of options. Let's give this service a new name that's reflective of the type of configuration we are trying to make. So for this example, let's pretend we are setting up a load balancing pool for, where, let's say, for example, the origins are in multiple AWS regions. So I'm going to call it AWS multi-region. Not too creative, but it'll serve our needs. You'll notice throughout the Link 11 portal, there are options for custom naming fields, which is really helpful if your organization uses a naming schema. Let's also use that example for a free text description of the configuration in the description field. You'll notice there's a default toggle using HTTP 1.1 connections. At this point, this is a pretty standard HTTP pipeline for communication between web servers, especially between the Link 11 WAP and your origin server. However, if you have an older origin server that you want to extend the life of and protect, and it only supports older protocols, you only need to toggle this option off. For our example, we'll leave it on. Next, let's define the load balancing stickiness model. As mentioned earlier, this configuration defines the methodology of the Link 11 WAP to ensure state and continuity to a singular backend instance for the duration of a web session. So in short, to make sessions sticky. The setting options are as follows. None is a default. This is where requests will be distributed across the endpoints in a round-robin fashion, according to the weights assigned to them, which I'll describe shortly. There's the auto cookie, where the Link 11 WAP will automatically generate a cookie to maintain the session on the same endpoint. There's a custom cookie, where you, the user, can provide the name of the cookie that the Link 11 WAP will use to track the session. For example, this could be one generated by an AWS or GCP load balancer. There's IP hash, where routing will be determined from the hash of a client and the destination address. And then finally, least connection, where requests will be sent to the endpoint with the fewest number of connections. For our example, we'll just stay with none. Let's move on to the transport protocol. Under transport, we have the following options. Per request, which is the default. Incoming HTTP requests will go over HTTP, and incoming HTTPS, the secure socket layer, requests will also go over HTTPS. So just a one-to-one mapping. HTTP always, this is where all communication between the Link 11 WAP and the backend will be over HTTP. HTTPS always. Again, overall communication between the Link 11 WAP and the backend will be strictly over HTTPS. And there's a port bridge mode. This is where the Link 11 WAP will use the same port as the incoming request. This is not limited to ports 80 and 443, which are the standard TCP ports for web. The Link 11 WAP will use whatever port was specified. Note, this mode is not available when more than one host is defined. For our example, we'll go with per request. Now that we have defined the communication protocol options to our origins, let's set up the actual origins themselves. Under the host area, near the bottom of the configuration panel, you see there are no entries. Click the new button, which is on the right-hand side here. Once selected, you'll be presented a new row with the following options you can modify. There's a host, which as described previously, this is where you configure the actual origin server with either an IPv4 address or a DNS record, CNAME or a record. There's the HTTP port. This is the ports for the backend server. The default is a standard port of 80, but you can specify custom HTTP ports if you're running a custom web application that listens on alternative ports. I've seen customers use port 8080 in an attempt to provide some obfuscation. Similar for HTTPS, same as HTTP except for the secure version of HTTP, which uses port 443 by default. But again, you can specify a custom port if so desired. There's a weight, which I briefly alluded to earlier. The relative weight of each server, this describes the relative weight of each server for load balancing purposes. The Link 11 WAP distributes traffic with a round-robin sequence according to these weights. So for example, if two servers are both set to 1, they will receive equal amounts of traffic. If the first is set to, let's say, weight 3, while the second is set to weight 1, the first server will receive 3 visitors for every single visitor that the second server receives. This makes it customizable to the capabilities of each member in your backend pool. There's max fails. This field sets the maximum number of failed communication attempts that are allowed for this server. Once this number of failures occurs, the Link 11 WAP will consider the server to be inactive. If other servers are available, the Link 11 WAP will fail over the traffic to them. So if this wasn't, let's say we only had one server available in the pool, the system will return an error to the client, with your standard HTTP error codes, whether it be a 504 or a 502, which is a bad gateway. There's a failed timeout, which is when a server fails. This is the length of time in seconds that the Link 11 WAP will wait before trying to send traffic to it again. And then finally, the is down check mark option. When this box is checked, the Link 11 WAP will not attempt to communicate with this server. This allows you to take the server offline gracefully for temporary maintenance or some other purpose. Once you have filled all fields, the check mark at the end of the configuration row will be selectable, allowing you to save the entry. You can then save the entire backend service or add another host to add to the available member pool, and shard your web connections across however you see fit. So let me quickly put one entry here just for the purposes of our example. I'll just use a bogus IPv4 address, keep the default settings. Maybe I'll set the max fails to 3, and then I hit check, and away we go. I can add another one if I wish with its own independent configuration. So let's say, not being very creative here, but you can see a different IP4 address. Maybe I'll use a different HTTP port. I'll say port 8080 and leave everything else in, and voila. So at this point, I can save it, and it should show up in the list of the backend services, and there it is. When you can see the 2 entries and have the option to go edit it again afterwards if need be. So by now, hopefully you can appreciate that without proper load balancing, a single server crash can take down your app. With the Link 11 WAP backend services, traffic shifts seamlessly, ensuring no downtime and consistent performance. And setting it up is easy. Just add your origin servers, choose a routing strategy, and enable health checks. The system handles the rest. No complex coding required. If you're ready to optimize your backend performance, try our origin and load balancing today and keep your applications running smoothly at scale. Till next time, guys.
Link 11.